Good afternoon, grade 9s. Hope you're well. Let's have a look at triangle theory that you've already done in grade 8. So it's just revision basically. And first up we have interior angles, which is another set of angles that add up to 180 degrees. Okay, do you see why we have to write reasons for our statements now? So our statement would usually be the part of the angle plus the angle B plus the angle C equals 180 degrees, and then your reason is right to the right here of angles in a triangle. So it doesn't matter what the triangle looks like, all the interior angles always adds up to 180 degrees. Then the next theory is the exterior angle of a triangle is equal to the sum of the two interior opposite angles. So this is where we have an exterior angle C1, and the line BC is produced to become BD. So this angle, they say in the theory, is equal to the same size as that angle plus that angle together. So the theory is, and the statement would be, like over here, C1 is equal to angle A and angle B together. Okay, so there's a little bit of theory and history behind how and why come, but I'm not quite going to explain it to you on here. We'll do that when we get back into class. Okay, so if two sides of a triangle are equal, in other words, it's an isosceles triangle, then the angles subtended by these sides are equal. So here are our given equal sides, and then automatically the gaps opposite them will be the same size because those angles come from the same line. So that means that angle B would be the same size as angle C. They would open up at the same gaps. So the way we write our reason, AB is equal to AC, that's given to us, and therefore angle C is equal to angle B. That's what we will solve then basically, and the reason for this is angles opposite equal sides. Okay, that's, you can see over here how we abbreviate it. Angles opposite equal sides goes with when you say in a triangle the one angle is equal to the other angle because of two certain sides given equal. Now into the next one, the converse is also true, that if two angles of a triangle are equal and given as equal, then the sides subtended by these angles are equal in length, and that's because they come from the same line segment, and then these gaps, because they're the same size, the gaps are the same, so the measurement here to fill in this side is the same as the measurement here to fill in that side, and therefore automatically they should be equal, okay, by reasoning. So that is B, not C. I'm just fixing that for you. So automatically we will have that AB is equal to the length of AC. And the way we write this would be to say C is equal to B, that's given to us. Then therefore AB is equal to AC. And the reason this time around is sides opposite equal angles. Okay, and you can see in both of these, if we have to solve for sides, then sides opposite equal angles. If we have to solve for angles, then angles opposite equal sides. Okay, learn this. All right, so how do we apply these concepts to certain questions? We're going to have a look at this example together. So notice the reasons are given when we make statements. Okay, this is so we know how, or show how we use theory to arrive at the answer. Just that again. So we're going to set up a statement reason here and then carry on. Okay, there we go. So we can have a look here at the question. Find the magnitude of each variable, giving reasons when necessary. Let's have a look here. So I can identify three triangles, the one being ADC, next one being ABD, and then also BCD. So in BCD we have been given equal side lengths BC and CD. So automatically we know the size of D, the variable D that is. Okay, so we talk about the variables when they're small lowercase letters. A is an angle of that triangle at angle D in that triangle, and then B is the equal angle there. So I'm going to start there, A, C, and D. B is in the other triangle, A, B, D. So just once again, we can use plenty of ways to solve each specific diagram. Sometimes there's just one way, but most of the times there are many ways. The first thing I'm going to do here is in triangle ACD is to find the value of A. I'm going to do this alphabetically, or try as far as possible to do this alphabetically. So I'm going to find A by using the interior angles of ACD. And so I know that it's 27 degrees, the one angle in the triangle, plus 84 plus 21 degrees. And this is only a section of this bigger angle over here, this angle at D. Okay, so it's 21 degrees and then A as well. That's in that angle that I essentially want to solve. So we know what about the interior angles of a triangle, that it adds up to 180 degrees. And your reason is interior angles of, and I'm going to be specific, and I want to teach you to be specific, to write in which specific triangle we're working here, because as I mentioned to you, there are quite a few. So this is of the triangle ACD. Now we add like terms, like I call it in class, tidy up. And if I add the 27, the 84, and the 21 from the left-hand side, I have 132 degrees. And then plus A that remains on the left-hand side should still add up all to 180. Then we subtract 132 from both sides to isolate A, the variable we want to solve, and that leaves you with 48 degrees as the size of A. So I'm not going to be able to solve this alphabetically. I could, but it feels right to just go to solving C next, because C is equal to A now that I have the value of A. So it's also 48 degrees. But now I have a specific reason here. New variable, new reason. You'll see. Okay, so here I started with A, goes with that reason. Now I'm going to start with C. Now I need a reason for saying the statement that I did here. All of this over here was just solving for the variable A with a statement that I made. So we're going to identify it as angles. We're solving for an angle, so it's angles opposite equal sides. That's the reason for that, because this was in one of the triangles. Let me just write smaller here. Let me fit it all in. Oh my word. Okay. So it is angles opposite equal sides, and I'm going to be specific again in triangle. What was this? BCD. Okay, once again, because there are so many triangles. Okay, so I'm just going to highlight this, that it's been solved. Okay, then we're going to solve for B. B is on a straight line with C, and we say B plus C's value, which we've already solved for. So we can say B plus 48 is equal to 180. Now I know there are other ways to solve this. If you want me to look at the way that you do things, and you have a different way that I did it, you can just send me a picture of what you've done and I'll have a look at whether it makes sense. So the reason, see again, we're starting with a new variable, so we need to have a new reason for this variable being solved. So that would be, like I said, adjacent angles on a straight line. And then we can solve it. and that would be by subtracting 48 from each side. We get that it is 132 degrees. And then we have only D left to solve, and D is an equal side. It's given that it's equal to BC. So we can easily solve D by just saying D is equal to 30 millimeters, because it's given that BC is the same length as DC. So you can see here, this and this are the statement and reason that go together. Okay, and then we can have a look at our worksheets that's in the back of all of this. So you'll see some of them are quite straightforward and some of them are more challenging. So I will, for example, suggest that you redraw the drawings, okay, in your book every time, and put a statement and a reason. The way I would teach it in class is you divide your book into 3 columns, or 2 would be better because then it's more space. And then you first draw the diagram, and then below it you write statement and reason, and you do the solving of the variables. And then you can also draw on the diagrams and indicate what you've solved and what is equal to what, and so forth. So I would, for example, write on my diagram, they said in the info below here, BE is parallel to CD, but it's not on the diagram. But if you've drawn it, you can, of course, write it onto the diagram. It's little things like that that help you solve values. And so you'll also see in the extra exercise the challenges, and I would recommend that people above 70% have a look at it. But on the other side, some people struggle with geometry. Some people just get it who don't get other things. All right, guys, have a lovely day.